In this chapter, I will discuss functions. There are two basic types of functions, those that are predefined by the C compiler and those that are defined by the programmer. Regardless of the type of function, functions serve three main purposes in a program. First, functions make problem solving easier by allowing programmers to break large and complex problems into small and more manageable tasks. Second, functions speed up program writing by allowing programmers to use existing code to perform common tasks. Third, because functions can be used as many times as necessary in a program, the programmer does not have to duplicate the code in different parts of the program. Demo 7 is a sample program which uses a programmer-defined function. A programmer-defined function can be either a value returning function or a void function. This one is a void function. A void function is a function that does not return a value. It simply performs a task. You may want to use a void function in a program to display information such as a title or column headings, something which does not require a calculation. In this sample program, a void function is being used to simply display a line in the output. Every function has three basic types. First, there is a function prototype. In this case, the function prototype is labeled void display line. Display line is the name of the function. Notice the parentheses, which indicates this is a function, but there's nothing inside of the parentheses. That's because nothing is being passed to this function. In order for a function to operate properly, it must have a prototype defined before it is called. Scrolling down in the program, you'll notice that there is a statement that simply says display line, followed by the parentheses. It also ends in a semicolon. This is the calling statement. This is how you tell C to use the function which has now been defined. And below the main function, you'll notice the programmer-defined function definition. In this section of the program, you tell C exactly what you want this function to do. In this case, all we want the function to do is to display a line of dashes across the screen, and then cause an inline to occur. And that's it. That's the purpose of this function. Notice the contents of this function is enclosed within the braces. I'll compile this program to observe its execution. It compiles normally, and then when executed, and I enter a number such as 9, you'll notice the row of dashes that is displayed. That is because the function was called to display this row of dashes after the user input and before the result of the calculations is displayed. The calculations themselves are rather simple. The square of the number is simply taking the number entered and multiplying it by itself, and half of the number is simply dividing that number by 2. As you can see, these calculations are performing correctly. Now, in reality, if all you wanted to do was display one row of dashes across the screen, then going to the trouble of creating a function might not be worthwhile. But if, however, we want to call this function multiple times, we can now do so by simply calling that function wherever we want it to be displayed. For example, if I would like that line to be displayed after the title result of calculations, I can simply call that function by typing display line and calling that function. If I also wanted to have that below the last line, I could do so. The point is that now we have a function that we can use multiple times. I only need one function prototype at the top, and I only need the function itself defined once. I can now just call this function each time by simply naming it. We'll recompile this program and then observe the run. I'll type in a 5 this time, and now notice the row of dashes have been displayed in each instance that I called it.